Hello everyone, I am Shankha Subra Sanyal and I welcome you all on behalf of S-Cube's classes. Well, I'm really thankful to all of you for your overwhelming response. The amount of love that you have shown through your mails, through your feedbacks, I'm really grateful. I'm really privileged. Well, last time we had a discussion on rational number. It's time for discussion on irrational number. So what are rational numbers and what are irrational numbers? We should be clear about it. In rational numbers, we have found that it should be in the form p by q, and where p and q are integers and q not equal to 0. Let us check what is an irrational number. The numbers that are expressible as non-terminating and non-repeating decimals when expressed in decimal form are known as irrational number. For example, every non-terminating and non-repeating decimal is irrational. Clearly, 0.101010001000 dot 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 is a non-terminating and non-repeating decimal. Check. In the first one there was 10, then it became 2, 3, so on and so forth. So it is a irrational number. Some other examples are also cited. This is, I'll call it as type 1 irrational number. Another type of irrational number is the type 2. If m is a positive integer which is not a perfect square, you come across this kind of terms in real life while solving problems of maths. Root 2, root 3, root 6, root 8, and so on. They are all irrational. That means it is in the form root over m. This is the second type. The third one, if m is a positive integer which is not a perfect cube. The first one was, it was not a perfect square. This is not a perfect cube. So it should be cube root of m. That means examples could be cube root of 2, cube root of 3, cube root of 5, and so on. This is the third type. The fourth type is pi. You must have heard about this term pi related to circles, right? So pi is represented by 22 by 7. Now this is 22 by 7 is a rational number, but pi, which is 3.14 and dot 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 goes on, is basically an irrational number. Please keep it in mind. 22 by 7, the value is rational, but when you put it in the decimal form, it is not a rational, but it is a irrational number. Let us look with some of the properties of irrational numbers. Irrational numbers satisfy the commutative, associative, and distributive laws for addition and multiplication. Well, sum of two irrational need not be an irrational number. For example, let us take 2 plus root 3 is a irrational number. So is 4 minus root 3. But 2 plus root 3 plus 4 minus root 3, the sum of these two is 6, which is a rational number. So it is not necessary that if two irrational numbers are there, then their sum would be irrational. It may be rational. Also, the difference of two irrational need not be an irrational. Let's take the example that is on the screen. 5 plus root 2 is irrational. So is 3 plus root 2. But then if I subtract the first and the second number, what I'll be getting? I'll be getting 5 plus root 3 minus 3 plus root 2. Root 2 gets cancelled and we are left with 2, which happens to be a rational number. Thus, we see that if we add or subtract two irrational numbers, it shouldn't be a rational, it shouldn't be a irrational number, it may be a rational number. Another example is for the product of two irrational. Let's say root 3. We know root 3 is an irrational number as we have just discussed. But if we make a product of root 3 into root 3, we'd be getting 3. Now this 3 is a rational number. The quotient of two irrational numbers again need not be an irrational. Just for example, if I have two numbers 2 root 3 and root 3, when I divide each and we'll be finding the number to be 2, which is a rational number, right? Also, sum of a rational and irrational number is irrational. Difference of a rational and an irrational number is irrational. Product of a rational and an irrational number is always irrational. And quotient of an rational number with a irrational number is also irrational. Well, we must note over here, if A is a rational and root B is irrational, then each one of A plus root B, A minus root B, A root B, and A by root B is irrational. There's an important result relating to irrational number. If A and B are two distinct positive rational numbers, then A plus B by 2 is a rational number lying between A and B. Similarly, root AB is an irrational number lying between A and B. Before going any further, let us take this question. Are the square roots of all positive integers irrational? If no, give two examples. Well, the square root of every positive integer is not always irrational. For example, root 4 is 2, which is a rational number. Similarly, root 9 is 3, which is again a rational number. Now, if I apply the same thing, extend our discussion to cube roots of positive integers, then we have that cube root of 8 is 2, which is again a rational number, while cube root of 27, which is 3, a rational number. That means not always the cube root of a positive integer is an irrational number. If we are asked to insert one rational number and one irrational number between 3 and 4, let's see how to go about this. A rational number between 3 and 4 can be easily found out. How? We'll take the sum and divide it by 2. Simply we'll take the average, that is 3.5. An irrational number that lies between 3 and 4 is the square root of the product of these two numbers, that is root over 3 into 4, which is root 12. If we are asked to find two irrational numbers between, say, 1 by 7 and 2 by 7, so by actual division, we know 1 by 7 is nothing but 0.142857 bar, while 2 by 7 is 0.285714 bar. Now, let us consider the numbers. A, which is 0.1601600160016 and B is 0.2121111211 So clearly A and B are irrational numbers such that A and B lies between 1 by 7 and 2 by 7. Hence, A and B are the required numbers. Suppose we are asked to find two rational and two irrational numbers between root 2 and root 3. By the way, this question came in 2014 as well as 2015. So what do we have? We know root 2 is nothing but 1.4142135, while root 3 is 1.732050807. If we consider the numbers 1.5 and 1.6, of course, if you check, they both lie in between 1.4 and 1.7. So we find that both of them are rational numbers such that root 2 and root 3, in between them 1.5 and 1.6 lies. But if I am asked to find the irrational numbers, we can write it in the manner 1.50, 500, 5000, and so on and so forth. Similarly with B, we can write 1.61, 611, 6111, and on. So now we get two numbers which are lying between root 2 and root 3, which are irrational to be A and B, right? We are asked to find two rational numbers in the form P by Q between 0.34344344 and 0.36366366. This question came in 2010. We'll be considering the first number to be A and the second to be B. Now see, 0.34 and 0.36. That means there can be a number which lies between these two numbers is 0.35. Now 0.35 is of course a rational number because it can be represented in the form 35 by 100 or in the simplest form as 7 by 20. Similarly, since it is 0.36366, I'm talking about B, so we can have a number which is 0.36. Now if it's 0.36, it is again a rational number because in the simplest form it can be written as 9 by 25. Thus, 7 by 20 and 9 by 25 are the required rational numbers lying between the two numbers that is given to us. So this brings us to the end of the lecture. Well, before I sign off, as I always do, I would request you, in case you have any queries, please do feel free to write to me at scubesclasses@gmail.com, or you can WhatsApp me on the numbers given on your screen. It would be a privilege on my part to be addressing your queries. Thank you so much.